I'm Bukola Joseph. So we are going to be doing experiment on Archimedes principle, and the question we are going to be treating is past question year 2000. Okay, year 2000. All right, look at it, 2000, and it's also repeated. It's a repeated question for 2012. Okay, this is 2012. It's a repeated question 2012. Okay, so I'm going to be using the setup for 2012. So let me read the instruction as we perform the experiment. Okay, now we have been given this apparatus. This is water, this is the other liquid, this is the liquid, this is the spiral spring, and this is slotted masses, and this is rotor stand that I'm going to be using as my support system. Now, what is Archimedes principle? Archimedes principle simply states that if a body is partially or wholly immersed in fluid, it experiences an upthrust which is equal to the weight of fluid that is displaced. Okay, now that we have the understanding, we are going to be performing this experiment. It says study the diagram above and use them as guide in carrying out the following instruction. Instruction 1 says using the spring balance, determine the weight of the object of mass m 50 gram in air. So it means that, sorry, let me remove this mass. I have to do this. It means that we are going to be weighing 50 gram mass in air, and we'll record its weight as W1. So this is going to be our W1. This is my water. Okay, I put my spiral spring. All right, let me raise it up so that I will be raising the water up instead. Okay, so we have this is my weight. So let me check my weight in air. So we have two ways of measuring. This is in grams, and this side is in newtons. So if you are going to be using the gram side to measure, it means you have to convert force to kilogram by dividing by 1000, and then you find weight. You know the formula for weight is what? M times G. Hello? So, but I would prefer to use the Newton side to avoid whatever conversion. Okay, so now this is my weight in air. It's not in water. Let me remove the water. Let's read weight in air. So as you can see, it is 0.5. So I have my weight in air to be what? 0.5 for 50 grams. 0.5. So I will still add 0. So to give me 0.50. Now the next thing, I want to run down W1 for all the masses, and then I will do W2 for all the masses. So let's do 100. I'm putting 100 now. I'm finding for 100. Okay, let's do 100. So let's do 400. So 100 is 1.0. So we have 1.00. Okay, so the next one I will do is for in liquid for 50 gram mass. I'll do for liquid in 50 gram for 50 gram mass. For liquid. So I'll put this now in liquid. Make sure it's not touching the beaker. Come, cameraman. So you can see it has dropped. Before, when it was in air, it was 0.5. Now it's 0.4. 0.4. So I'll measure it. So for W2 is weight in air. So we have 0.40. So I'll do 400 now. Thank you, dear. So we'll do 400 now. 100. I change it to 100. Do for weight in water. So this is it. What is our reading? Make sure it's not touching. So we have 0.8. It's on 0.8 Newton. 0.8 Newton. So we have 0.8 Newton. So we have found this. Now we are going to find U. U is simply the upthrust in water. and V is the upthrust in the liquid. This one is for the upthrust in water, U, and then this V is for the upthrust in what? The liquid. So we are going to find it and then record here. W3. So the W3 is weight in the liquid. We have found weight in water. Okay. Now we have found weight in air. We have found weight in water. Now we want to find weight in L, which is the liquid. Okay. So this is 50 gram mass. So we'll dip it into the liquid. All right. Completely. What is our reading? What do we have as our reading? 0 is not up to 0.4. This is 0.3, 0.3, 32, 36, 38, 0.38. So we have 0.38. Okay. So we are going to add 50 gram mass. I don't know if it will stay. Let me just remove this one and put 100 straight. So put 100 gram mass. So let's read it. What do we have? What do we have? 0.82, 0.84. We have 0.84. 0.84. Before, okay, this you'll be asked to find U is simply the upthrust in water, which is W1 minus W2. So if you do 0.5 minus 0.40, you have this. So, and this W1 minus W2, you have this. W1 minus W2, you have this. This minus this, this minus this, you have this. Okay, now the V is the upthrust in the liquid. Upthrust in the liquid. This is for the V. All right. Now it's simply weight in air, which is W1, minus weight in the liquid. Okay. So this is weight in air. W1 is weight in air. W2 is weight in water. W3 is weight in the liquid. So to find the upthrust in the liquid, we do weight in air minus weight in the liquid, which is 0.5 minus 0.38. You have this. This minus this, you have this. W1 minus W3 will give us this, and so on. All right. Now we know. So for this experiment, you'll be asked to plot the graph of U against V. Okay. Now this graph gives us the information of what? The relative density of the liquid. Okay, which is usually found via slope all over the density of water. Okay, so the relative density of the liquid, of this liquid, can be found via the formula slope all over the density of the water. If you enjoyed this experiment, please comment, like, and share. I'm Bukola Joseph, the physics enthusiast. Bye.